Hello everyone, Mr. Schultz here. Welcome to Integrated 2, Chapter 1-4, Inequalities in One Triangle. So, while we begin and jump into the comparison property of inequality. Well, if we have like two numbers, let's call them A and B. We don't know what they are, but we know we have two numbers, A and B. We understand that, A can be less than B. We understand that A could be greater than B, or finally, A is equal to B. There's only three things that A, if we compare A to B, that's only the three things that could happen. All right, so let's continue. Now, we do have this transitive property of inequality. So basically, if you remember the transitive property of equality, we said, okay, if A equals B and B equals C, then A equals C. Well, this one's going to be a little bit different using inequalities. If A is less than B and B is less than C, then, forgot my if, then A has to be less than C. That's it. Now, the reverse is true. Like if A is greater than B and B is greater than C, then A has to be bigger than C. That's it. Let's go on. So we have the addition property of inequality. So if we have two numbers and we know that, hey, look, if, now this is all like if A is greater than B, then if we add the same number to A as we add to B, then A plus C will still, get out of there. A plus C will still be bigger than the quantity B plus C. Now, get out of there. Why do you keep doing that? I don't want that. If A is less than B, then, if I have A plus C, will still be less than B plus C. If you add the same number, like it's not going to both sides. It's not going to make one side bigger than the other side all of a sudden. Life doesn't work like that. All right. Subtraction property of inequality. Well, the same thing right here is going to happen. If A is greater than B, then A minus C is still going to be greater than B minus C. If A is less than B, then A minus C is going to still be less than B minus C. It's pretty much, hey, it's still going to be smaller if we do the same thing on both sides. All right, let's continue. So if you remember the exterior angle theorem, we understand that, hey, look, these two will add up to E right there. So basically, we have this new theorem, the exterior angle inequality theorem. This pretty much states the measure of the exterior angle of a triangle is greater than the measure of either of its corresponding interior angles. Let's write that in. Interior angles. So that's pretty much saying, let's call this A, this B, and then this right here, let's call this D, because this is C. D is the exterior angle. It's pretty much saying, hey, look, D is going to be bigger than A, and D is going to be bigger than B. That's it. That's the inequality theorem. It's like, hey, this exterior angle is bigger than that one and that one. All right, let's do an example. I think it's actually our first example, example 1. So use the exterior angle inequality theorem. So we're going to find the measures of that are smaller than the measure of angle 1. Okay, well, angle 1. Okay, so we understand that, hey, look, this guy, we don't know if hypothetically, we don't know if it's going to be, bigger than measure of 8, or the measure of angle 8. Because technically we could draw this inaccurately. But we know that it's going to be bigger than, it's going to be bigger than PQR, which is right here. This one right here. PQR. Because that's the interior angle. So angle PQR is smaller. And we also know that QRP, so that's this one right here, it's going to be bigger than angle QRP, also known as PRQ. It doesn't matter which one, how we name it, as long as we have the vertex as the middle letter right there. Now, using that, we can also understand a few things. We can understand that, hey, look, PQR is made up of angle 3 and 4. So we could say, hey, look, angle 3 and angle 4 make up PQR, so they're going to be smaller. Well, we also know that, hey, look, 5 and 6. So angle 5 and 6. How do we know that? Well, angle 5 plus angle 6 is angle QRP. So we're going to leave it at that. Those are the angles we know for sure, because every other angle could be, unless it's labeled, could be bigger, but we don't know. We aren't given any information other than that, hey, this is an exterior angle, so it has to be bigger than the interior angles. So it says B, find the measures that are going to be greater than the measure of angle 8. All right, so this is angle 8 right here. So we don't know if angle 1 is, and we don't know any of these measures right here. This could be an inaccurate drawing. We don't know. But what we do know is that any exterior angle is going to be bigger than its interior angles. And so if we look right here, we see angle 2 right here. Angle 2 is the exterior angle. So angle 2 is going to be bigger than PRQ as well as angle 8. So angle 2 is greater than, or the measure of angle 2 is greater than the measure of angle 8. All right, that's it. Let's go on. So we're going to be talking about the angle side relationships in triangles. So let's talk about it. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. And the other thing is true. If one angle of the triangle has a greater measure than another angle, then the side opposite the angle with the greater measure is longer, should be longer right there, yeah, longer, than the side opposite the angle with the lesser measure. Well, what does this mean? So let's go over example 2. So the sides are going to be, let's see, MN is 5.4. So that's the smallest one. How do we know? Well, because the other ones, ML is 6.1. So 5.4, 6.1, and then we have LN. Now we could name these like NL and LM instead, but this is fine. So what this is saying is the smallest angles are going to be opposite. So angle L, angle N. So angle L is opposite MN. So that's going to be the smallest angle. The next one is angle 6.1 N. And then finally, the largest angle will be angle M. Now you might be like, hey, Mr. Schultz, why didn't you say LMN? And why didn't you say LNM for these? Well, if there's only one vertex, if there's only one angle associated with the vertex, we can name the angle just that vertex. It's a little helpful for us. All right, let's go on to the last page of our notes. Example 3. This is our last one right here. So example 3 is, order the triangle side lengths. List the side of the triangle in order from shortest to longest. Well, the first thing that I see here is I don't know what the angles are, but I do. Now, I know the triangle angle sum theorem states that, hey, look, they add up to 180. So I know that angle Y plus angle W plus angle X will equal 180. So if I substitute the information, I know that angle Y is 90 degrees because it's the definition of a right angle. So 90, and then angle W says it's 51 degrees. How do I know it? Because it is the given. So anytime they give you the information, it's called given information. It's given. And so now we have, okay, what is angle X equal to? Well, a nice way to figure this out is to actually just, subtract, like solve for X. Hey, this is like algebra right here. So if we were to add these together, I'd get 141 degrees plus the angle of X is equal to 180 degrees. And then if I want to subtract by 141 degrees on both sides, I would get, what was that? 39 degrees is equal to technically the measure of angle X. So now I know the order. I know that angle X is the smallest, followed by angle W, and then the largest angle is going to be angle Y. So now I have figured out the order of the angles. Now I can write in the order of the sides. So across from angle X is WY. And then across from angle W is YX. And then the last side, that would be the longest side, is WX. Now, if you switch the order of these two vertexes, these two letters, that's totally fine. All right, guys, we cut this one a little bit shorter, and I'm really happy about that. I'll catch you guys in class. You guys have a wonderful night. Bye.